to the last video of our very short unit. We're going to look at restricting composite functions. In example 1, we're going to state the domain and range of each. Then we're going to graph the composite function and state its domain and range. So first, the domain and range of f of x is going to be the same because it is a linear graph. So it's going to be from negative infinity to positive infinity. Then for g of x, our domain is going to be negative infinity to positive infinity because this is a parabola, but your range is going to be slightly restricted because we have a vertex at 0, -2. So your y values are going to be from -2 on to infinity. Next, we're going to graph the composite function. We have to find the function for g of f of x first. So f of x is 2x minus 1, and we're going to insert that 2x minus 1 into our g of x function. Okay, so then what we have here is a parabola with a vertex at 1/2, -2. So we're going to go ahead and graph this. So our vertex is going to be here. And then we can find another point if we want to. So I'm going to pick x equals 0 and x equals 1 and put it into our g of f of x equation. So that's 2 times 0 minus 1 all squared minus 2, which is -1 squared minus 2, which is 1 minus 2, and that's -1. So that is my next point over here. Then I'm going to go ahead and do it for x equals 1. That'll be 2 times 1, which is 2. So that's 1 squared minus 2, which is also -1. That's our second point. I'm going to connect these points and continue a bit. So that's our graph for our composite function. Our domain is from negative infinity to positive infinity. Can have any x value, and our range is going to be from -2 to infinity. Now looking at g of x, we're going to find our graph, the function. So g of x is x squared minus 2, and then we go ahead and plug this x squared minus 2 into the g of x function. And if we expand it on this, it's going to be x to the power of 4 minus 4x squared plus 4. That's coming from just here and expanding because that's x squared minus 2 times x squared minus 2. We still have that -2 at the very end from here. Then I'm going to simplify one more time. This is our polynomial. So there are several methods for us to graph polynomials from the very first unit. I am just going to do a table values. And I'm going to do quite a few points. So I'm going to do -2, -1.5, -1, 0, 1, 1.5, and 2. And then we're going to go ahead and plug this into our polynomial to find its y value. And this is going to be 2. This, I understand, it's kind of hard to do in your head, so you can use a calculator for that. It's going to be about -2. Then at -1, if you put this back into your polynomial, you're going to get back -1. Put in 0, that's 0 minus 0 plus 2, which is just 2. At 1, you're going to get a -1. If you put this into your polynomial, at 1.5 is going to be about -2. And at 2 is going to be 2. If you didn't want to do this, you could have used what we learned about doing our sign diagram and factoring out this x to the power 4 minus 4x squared plus 2, that's another option as well. I'm going to go ahead and plot these points. So our first point is at negative 2, 2, then negative 1.5, negative 2, then negative 1, negative 1, 0, 2, 1, negative 1, negative 1.5, negative 2, and then 2, 2. So I'm just going to connect the points from left to right. It's going to just look something like this. Then extend the arrows on each side. And that is your graph. So for your domain, it's going to be from negative infinity to positive infinity. For your range, we approximated this to be about negative 2. So I'm just going to say somewhere around negative 2. It does touch it. And if you want the exact number, we would have to plug this back into the function. And our y values continue from there. We're going to do the same thing, but for example 2, and we're going to get some rationals. So we're going to find g of f of x. So f of x is 1 over x minus 2. And we're going to insert this into g, so that's going to be 1 over x minus 2 all squared minus 1 over x minus 2. I'm going to continue and simplify this. And I'll try to get this as a 1 fraction. So I do need a common denominator for that. I'm going to multiply the second fraction by I'm going to multiply it by x minus 2, top and bottom. And then combine our fractions in the numerator and leave the denominator alone. So we're going to have 3 minus x all over x minus 2 all squared. That is our rational. And then we just need to find the domain. So our only problem spot is when x is equal to 2, because then we have a non-permissible value at x equals 2 because we're going to get a 0 in the denominator. So when I'm writing out the domain, I am not going to include 2. So negative infinity to 2 and 2 to infinity. So at x equals 2, we have a vertical asymptote there. Now we're going to do it for f of g of x. So g of x is x squared minus x. F is 1 over x minus 2, but we're going to plug in x squared minus x instead. I'm just going to factor this in the denominator. So that's going to be x minus 2, x plus 1. All right, so we have two non-permissible values, which is located at x equals 2 and x equals negative 1. So we can't have x to be 2 or negative 1, or else we can get 0 in the denominator. So then our domain is going to be everything except that. So from negative infinity to negative 1 and negative 1 to 2 and 2 to infinity. You could also say that x is the element of the reals where x can't be 2 or negative 1. So we can also use set notation or interval notation depending on what's more comfortable for you. Now I want you to do the try it yourself on your own, and then when you're ready, press play for the solution. In this try it yourself, we're going to find g of f of x, and we're also going to find f of g of x. So for g of f of x, that's g of the root of x. And then we're going to put in the root of x into each term in the g of x. So that's negative root x all squared plus 2 root x. The root x and the squared are going to cancel, so we're just left with negative x plus 2 root x. If you think about our domain here, we can insert anything to this term, but for this term we are restricted. We can't have any negative numbers. So that means our domain is going to be from 0 and any positive numbers after that. For the next one, f of g of x, it's going to be f of negative x squared plus 2x. Then we're going to put it underneath the square root sign because that's the function of f. I'm going to factor this. It's going to be negative x, x plus 2. It's going to be negative x times x minus 2. And this whole thing needs to be greater or equal to 0. In other words, we need negative x times x minus 2 to be greater or equal to 0. And then if I divide both sides by the negative, to the rule of inequalities, we're just going to switch our sign to the other side. And now we're going to have x times x minus 2 is smaller or equal to 0. Because remember, when you divide by negatives on both sides of the inequality, you have to flip your inequality sign. Okay, so for this, in order for this to happen, our critical points here are 0 or 2. So if I draw this on the number line, these are our critical points. You can check each interval in between negative infinity to 0, 0 to 2, and 2 to infinity. However, we want this overall thing to be smaller or equal to 0. So if I pick in a number in between negative infinity to 0, let's just say I'm going to pick negative 1. And if I put it in there, we're going to get negative 1 times negative 1 minus 2. This is a positive number, it's larger than 0. So that means that this is not true, it doesn't exist here. Now let's try 1. If I put in 1 into here, we're going to get 1 times 1 minus 2. And that is going to be negative 1, which is smaller or equal to 0. That inequality is satisfied, so we're good. Lastly, let's pick x equals 3. That's 3 times 3 minus 2. It's supposed to be smaller or equal to 0, and it's not. It's actually greater or equal to 0. So it's not good. So all I did was use this here and see when is this true in what interval. And it's true between 0 to 2, which means our domain is going to be from 0 to 2. One more example, we want to determine possible functions for f and g so that we have f of g of x. All right, well, the better way to think about it, the very outside function should look something like this. We could say that f of x could look like 1 over x. So what would g of x look like? G of x has to somehow get us an x squared here. So what if g of x was just x squared? Then we can check our work to see it's true or not. So f of g of x, which is x squared, is then equal to 1 over x squared, and it is true. Let's do another one. Our very outside function, we have something to the power of 4. So why don't we let f of x be x to the power of 4, and then g of x to be anything on the inside of that, so 3x plus 1. Now we'll check our work. So g of x is 3x plus 1, and then we insert that into f. So that will be 3x plus 1 to the power of 4, and it works out. Try the last one on your own. When you're ready, press play for the solution. So for this last example, we're going to let f of x be what the outside function looks like, and it looks like the square root sign. So we can say it's just going to be the square root of x. Then g of x can be 3 plus x. Let's check our work. So that's f of 3 plus x, and then insert into the root sign for our f of x function, and we are good.